Hi, and thanks for tuning in again. I'm Ari with iGROW, and today we're going to talk about a big issue that we've been getting asked a lot about from our indoor gardeners, especially because iGROW is such a new technology to most of you. And that's the question of light penetration. This is a great topic for us because it gives us the opportunity to talk about two of the most important things about the iGROW light that really makes it shine: light intensity and light quality. First, I want to take a minute and share a recent letter we received by a highly regarded indoor grower from Colorado, detailing his experience and initial observations after using iGROW for the first time. It's interesting to note that in reviewing iGROW, light penetration and light quality are two major focuses for this grower, and we think it'll be for you too. Recently, I was able to do a side-by-side test of the iGROW induction lighting system and a 1,000-watt high-pressure sodium with digital ballast. First, I noticed that the penetration of light in a 4x4 area was around 6 feet of penetration through the plant canopy from the iGROW, and around half of that for the 1,000-watt HPS. Part of this, I imagine, is because you can put the iGROW light so much closer to the leaves than the high-pressure sodium due to the low heat. Second, the size and shape of the iGROW bulb allows for a much more even distribution of light waves and deeper light penetration. Along with the hood and additional wings that added another 2 feet to the hood, allowed the iGROW to outperform the HPS in light penetration and coverage. Later in this video, we'll actually demonstrate what this Colorado grower was experiencing and seeing with his iGROW light. But first, let's focus on light penetration, what that means, and the science behind it. What growers mean by light penetration is the light's ability to penetrate or travel through the canopy so the plant can yield more fruit over a bigger area beyond and below the top surface. So obviously, this is a function of light intensity, right? The more intense the light, the greater the penetration. That's the main reason a 1,000-watt high-pressure sodium is the most widely used grow light in the industry. Of course, that seems reasonable assumption. However, not exactly how the science of light penetration actually works. And when applying that assumption to plants, we need to ask if it is actually accurate or applicable. Let me explain those two thoughts. The science of light penetration, as explained to us by one of the USDA scientists who worked with us in iGROW, is that light cannot penetrate through a leaf or a branch or even a tomato. So when you have a heavy foliage plant like a tomato, much of the light is being blocked by the top plant structure itself, which is why many of you are constantly trimming your plants and trying to expose the flowers and fruit to get more light. That is obviously helpful and useful, but the practical science of light penetration is that the top canopy area that is getting pummeled with the most intense light actually feeds its light energy down to the flowers and fruit below. So the broader the area you can provide with the highest usable light and intensity, the better the yield over a wider area. In this regard, a significant limitation of HID light is that the bulb is relatively small, especially compared to the iGROW bulb, and when it's hung 20 inches or more above the plant canopy, the great light intensity it provides at its core is then greatly diminished over space and time. Since an iGROW bulb is 5 times larger than a HID bulb, the iGROW light can deliver the same kind of intensity found at the source of an HID light over a much longer and wider area. The iGROW lamp intensity is further amplified because it's just hung 6 to 8 inches above the canopy, delivering very even, very intense light over a much bigger area. And we're going to show that to you. Using a 4x4 area as a recognizable desired coverage area for a grow light, we took a 4x4 foot piece of pegboard and then centered a standard 1,000-watt HPS light reflector over the board at 20 inches above that board, representing the top of the plant canopy. We then built a track so we could slide our par meter from end to end, side to side, and diagonally, and then took measurements every 12 inches in all directions. We took the center measurement, its highest intensity, and calculated the percentage drop off from the center point. We then did the same thing for our iGROW 400 watt light. So here's the data. At 20 inches above the canopy, the HID at the center point hit 1022 par. Left to right at the first 12 inches away from the center point, it went down to 580 par. That's a 43% drop. And another 12 inches away at the outer end of the 4-foot area, it went down to 136 par, a drop of 87% from the center point. The iGROW light at 6 inches above the canopy at the center point hit 1045 par. Left to right at the first 12 inches away from center, it hit 1001 par, less than 4% reduction. At another 12 inches away from center, at the outer end of the 4-foot area, it went down to only 580 par, and that's only 45%. We did the same test side to side, and iGROW outperformed the HID at every 12-inch marker. Why would you use any other light? Thanks for tuning in. Check out our other videos and follow us on Twitter at iGROW Lights and visit our website at iGrowlights.com.